Welcome back to eTech. Today we are going to learn about the progressive cavity pump. It is also known as the helical rotor pump, the mono pump, and even the eccentric screw pump. So what exactly is a progressive cavity pump? A progressive cavity pump is a type of positive displacement pump. It moves fluid by forming small, sealed pockets called cavities. These cavities are created in the space between two main parts, a single helix metal rotor and a double helix rubber stator. Now that we know what it is, let's see how it works. For the pump to operate properly, the internal parts, especially the rotor and stator, must be protected from abrasive materials. Inside the pump, the rotor rotates within the stator, creating a series of sealed cavities. Each cavity traps a small amount of fluid. As the rotor continues to turn, the cavities move forward along the length of the stator. The fluid moves with the cavities toward the discharge end of the pump. Because the cavities move continuously, the pump delivers a smooth and steady flow, even at low speeds. This gentle action makes the pump ideal for thick fluids, slurries, pastes, and fluids that contain fragile or soft solids. Main components of a progressive cavity pump. Now that we understand how the pump works, let's explore the main components that make this motion possible. Rotor. The rotor is a polished metal screw with a single helix shape. It rotates in a slightly off-center, or eccentric, path. This eccentric motion creates the moving cavities inside the stator. These cavities carry the fluid forward through the pump. Stator. The stator is made from elastomer rubber and has a double helix shape on the inside. It forms a tight seal around the rotor. This seal ensures the cavities remain closed and the fluid flows steadily. Without it, pressure would drop and the flow would be inconsistent. Drive shaft and coupling rod. Because the rotor moves eccentrically, it cannot connect directly to the motor. The drive shaft and coupling rod transfer rotation while allowing this off-center motion. This flexible connection is essential for smooth and reliable operation. Suction and discharge ports. At the suction side, the cavities open and draw fluid into the pump. As the rotor turns, the cavities close behind the fluid, while new cavities open ahead. This action gently pushes the fluid toward the discharge side, creating a continuous, smooth flow. Bearings and mechanical seal. Bearings support the drive shaft and keep it properly aligned. A mechanical seal prevents leakage around the rotating shaft. Now let's look at where these pumps are used. Progressive cavity pumps are found in many industries, especially where fluids are thick, heavy, or sensitive. In wastewater treatment plants, they pump sludge and grit. In the oil and gas industry, they lift crude oil from wells, even with sand or gas present. In food processing, they move peanut butter, sauces, and dough without damaging the product. In chemical plants, they handle thick or corrosive liquids with controlled flow. In agriculture, they pump manure, fertilizer, and feed mixtures. And in mining, they transport abrasive slurries safely. These pumps have many advantages. They provide a smooth, non-pulsating flow. They can handle very thick and viscous materials. They can pump fluids containing solids without damage. They are self-priming, even when the suction line is not full. They produce low shear, protecting sensitive materials. And they deliver a constant, predictable flow at different speeds. Like any device, they also have some limitations. The stator can wear out quickly, especially with abrasive fluids. It is not suitable for very high-pressure applications. Its flow rate is generally lower. Thanks for watching eTech. If you found this video helpful, like, share, and subscribe. See you in the next video.